Hey calculus kids, this is Dr. Callahan with week 16 Thursday. How are you guys doing? The following 3 questions are for your warm-up block, so go ahead and pause the video and answer them. All right, let's go ahead and get started with this then. So warm-up is due in week 18. This is week 16 Thursday. So you guys have, another week and a half to kind of play around with this and get everything done. It is going to be for 300 points, and then I will give you guys instructions on how to go about turning that in, so don't worry about that. I'm going to go ahead and get started with your MS team. So if you take a look over here, this is week 16 Wednesday calculus. So this is for, actually it's today. I'm always making the video a day ahead. So it's actually Wednesday today, but in order to get your points for attendance and also to be marked present, make sure you guys click the view button, the view assignment button. And once you do that, you can go ahead and watch the video. But then also I have attached the 2 things for Wednesday in addition with your guided notes and also the video itself. So it kind of goes along with that. And then you just make sure you take a photo and upload it. Also on here is your updated grades. Everything is categorized based on your student ID. And so far, most of you guys are doing okay on average. I think you guys have about 70.16%. What's remaining at this point is you have your week 16 Math Excel, week 17 Math Excel, and then you have your week 16, week 17 AP College Board assessments on Wednesday, and then you have a final and your warm-up block to turn in, and that's basically it. So you have about 6 more grades going into the grade block, but overall this looks pretty good for the most part. There's a few of you guys that are kind of like very close to passing, but you still need to push yourself a little bit further. What I would recommend you doing is make sure you completed your Wednesday's AP College Board assessments, because in this class, remember, we don't have tests, you have your weekly assessments on that. So that's the first thing that I would recommend getting started with. The second thing is go back to your Math Excel and then complete the assignments. They are still open, so you're welcome to do that. The recommendation is if you didn't do so well on the AP College Board Wednesday assessments, there is the corrections that you guys can do. So that's another opportunity. And then lastly, today I actually have an extra credit for you guys if you would like to do it. But other than that, we're kind of at the end of the semester. And so you need to really kind of figure out what it is that you want to do, or what else you can do to raise your grade. All right, so with that said, I'm going to go ahead and add today's assignment. So today is week 16, Wednesday, or Thursday, excuse me. Let's see, copy. And let me make sure I'm on the right screen. I am. Okay, so week 16, Thursday, CalcAB semester 1. And today you guys are going to be talking about optimization versus related rates. And interpretation of, well, actually, it won't actually let me type this in. So I'll just go ahead and stop right there. That's fine. Your instructions are to view the assignment for attendance purposes, watch a video, comment, fill out the guided notes, take a picture of your work, upload it, and then your today's video, which I'm making right now, but it will be updated by 8:30 of Thursday. And make sure you guys jot down your guided notes. The video itself generally is not super long because at this point, we kind of went over everything that you guys need to know for this class. So if the video is only 10 minutes, it's not to say once you finish a video, you just go about your day. The other 40 minutes, I give you explicit instructions as to what you should be doing, such as make sure you read this article, make sure you take a look at this problem. Once you're done comparing, contrasting these 2 problems, answer the following reflection question. So make sure you guys are making use of the day for about 50 minutes. If you have any questions, I do have a daily Zoom. It's not mandatory, it's optional, but it's the same link, same meeting ID, same passcode from 10:10 to 10:30 every single day. And then if you need additional tutoring assistance, we can talk about it during that time, and then I can send you a separate Zoom meeting. If you need a copy of your hard copy of your guided notes for week 16, 17, 18 of semester 1, and then I have all of your guided notes for week 1 to 9 of semester 2 printed out. They're outside of B1. It's the building closes at 3:30 Monday through Friday, so you're welcome to stop by anytime. You don't need to let me know. It's just outside, so you're welcome to just grab one. Here's my email address if you have any questions. If you do need to have your calculus guided notes, I do have the tiny URL right here that you can access to. And if you do need to make some corrections to your Wednesday assessments on AP College Board, this is a template right here. Show the work and then take a picture and then just email it to me, which is completely fine. So 10 points, it's due on Thursday, and I'm just gonna go ahead and sign right here. Okay, and then of course you can see the assignment right here. This is what it should look like. And just keep in mind that once you guys click on it to view it, it will show me right here, it says viewed. Now, once you turn it in, this will change into turned in. So make sure you guys are doing that. All right, so then along with this, if you don't have your guided notes, I'm gonna make sure that I save a PDF document of it, and I'm gonna attach it to the posting. So that way, if you have a printer at home, you are welcome to go ahead and do that. So let me just go ahead and change this a little bit, PDF. It's saving, it's taking a little bit of time. Hopefully I'll get there. Okay, so while it's doing that, I'll go back to it later. So let's go ahead and get started with today's stuff. My little boys wanted to share some of their jokes with you guys, so I'm gonna share it with you guys here. I think my favorite one is, what do you call a snowman party? A snowball. I thought that was pretty cute. All right, so from your last class, which I talked to you guys about, not Wednesday because you have your AP College Board assessment on Wednesday, but from Tuesday, we went over several different optimization problems. You guys had the work given to you guys, and so let's go ahead and just briefly take a look at this example right here. It says a rancher has 200 feet of fencing with which to enclose 2 rectangular corrals. What dimension should be used so that the enclosed area will be maximum? So as I'm looking at this right here, I think about what is my primary equation and what is my secondary equation. Given the fact that the question says what dimensions should enclose area, my primary equation is going to be the area of this rectangle. Okay, but if you look at the area of this rectangle, you have y and x, so you have 2 unknown variables. You don't want that because you want to have just one unknown variable, which is just x or y. So that's where your secondary equation comes in. Your secondary equation, its sole purpose is to go ahead and solve for one of the variables, so you can substitute it back into the primary variable, and that way you're left with just one independent variable instead of having 2. So looking at this, the question is asking for area, but also since we're talking about fence, it's talking about perimeter. So the perimeter of this will be your secondary formula. So let's go ahead and take a look at this. My area for this rectangle is just going to be x times y because that's how you find the area, just length times width, x times y. So that's what I have right there. The perimeter of this is going to be me building a fence around this enclosed area. So just keep in mind that you have 200 feet of fencing, so perimeter equals 200, to which enclose 2 rectangular corrals. So then as I'm looking at this, how many x's do I have? 1, 2, 3, because my fence is going to have to go there. So 3x plus 2y equals 200. I always like to have everything in terms of x. So what I'm going to do with my secondary equation is let's go ahead and solve for y. So then I can substitute y into the primary equation with in terms of x. So then looking at this, if I were to solve for y, I will have to subtract the 3x on both sides divided by 2, and this is what I have. And I'm going to take this number and plug it right here for y. So my area now is a equals x times 100 minus 3 over 2x. Okay, so I want to distribute this, of course, so prep this up and set it up so I can go ahead and find the derivative. So once I do that, I need to find the derivative of this. It's just a simple power rule. So derivative of 100x is just 100. Derivative of negative 3 over 2x squared, bring down the 2. The 2 and the denominator cancels out, and you have 3x to the 1 power. So that's your a prime. Now I need to go ahead and find the critical point, because remember, we're trying to find the critical point that tested for the maximum. So I know ahead of time that once I do a f prime of x on the left side, f prime of x on the right side of this critical point, to be a maximum, you have to have a positive slope followed by a negative slope. So let's solve for x for critical points. Set it equal to 0 minus 100 divided by 3. Your critical point is going to be 33.33 feet. So then I want to do a sine line. So my critical point is 33.33 right here for x. I'm going to pick f prime of 0 on the left side of this, which is going to result with a positive, because if I plug in 0 into the a prime right here, I know that 3 times 0 is 0, so 100 minus 0 is 100. So that's a positive slope, okay? So that verifies that. The f prime on the right side of my critical point, so I use x equals 40 just because it's, it's not too big of a number, but it's also like it's not like a decimal or anything. So then I put 40 right here for 3. 40 times 3 is 120. 100 minus 120 is a negative 20. So I know that f prime of 40 is going to be a negative slope. So that does verify that I am looking at a maximum. So it goes up with a positive slope, down with a negative slope. So if my x is 33.33, so I know that these three x's here is going to be 33.33 feet. What is my y going to be? Because the question is, what is the dimension that should be used to maximize the area? So to find the y, you know that the area is x times y. So looking at this part here, actually you won't be able to figure out the y value using the area formula, because I don't even know what area is yet. So let's take a step back, maybe go back to the prime or the secondary equation. Because here I have y equals 100 minus 3 over 2x. So if x is 33.33, take that times the 3 over 2, and then take 100 minus that, which will give you 50.5 feet for the y. Okay, so now that you have x and y, these are the dimensions. These are the dimensions to maximize the area, 33 feet by 50.5 feet. Then what is your area? So you use your primary equation. Your area is going to be 33.33 times 50.5. So that is going to give you 1,681.65 feet squared. And this is your answer here. So that is optimization. So you always have two different equations, primary, secondary. You use a secondary to answer the primary question, and you go from there. All right, so in addition to that, I also want to kind of go over the things that you went over yesterday on week 16 Wednesday. So the first part of this was 4 questions on AP College Board on optimization. The second part of your week 16 Wednesday was that you needed to go ahead and do a fill in the blank concept check. And so I just want to take a moment to kind of go over this so that way you have that to correct as well. So this is the chapter 3, unit 3, and optimization is really our last skill. So we're kind of at the end of unit 3 at this point. So let's just go ahead and take a look at the answers here. We started off unit 3 with talking about extreme value theorem. So if a function is continuous on a closed interval, then both the absolute maximum and the absolute minimum on the closed interval. Here are some of the steps for finding extreme value theorem. Find the critical value by setting f prime of x equal to 0, and then confirm the critical points that are located on a closed interval. And remember, if we have a critical point, it has to be between the intervals, or if it's not an interval, then really you're not looking at that window for max and min. So that's something a lot of students forget, especially on the AP exam, and they deliberately set up the questions like that to make sure that you are checking, because if you're not checking, you will select the wrong answer. Because even though this might be a maximum, but that maximum is not on the interval windows of what they're looking at, then it's the incorrect answer. 3, find the critical values by setting the numerator and the denominators Find the absolute extrema by plugging in the critical values and the endpoints on f of x, and the max and min are the highest y value. Okay, so that's the first part. Second part, we talked about mean value theorem of unit 3. If a function f of x is continuous on AB and it's differentiable, meaning that you can find the f prime of x, then there must be at least one point that's called C that's in between A and B where the slope of the tangent is equal to the slope of the secant line. And the formula for this is just a slope formula. So f prime of C is equal to f of B minus f of A divided by B minus A. So here are the steps to apply MVT. So to determine if the function is continuous on the closed interval, you want to look at the vertical asymptote, and that's going to be located in the denominator. To determine whether the function is differentiable, you want to look at the critical points in the denominator of the derivative function. Next thing we talked about after MVT is Rolle's theorem. Rolle's theorem is actually kind of the easier version of MVT because you don't need to find the slope formula. MVT, the slope could be any number, but for Rolle's, it's specifically a horizontal slope, which is just 0. So if the function is continuous in AB and it's differentiable, meaning that you can find the first derivative, then you know that f of A equals f of B. And there has to be at least one point C in between A and B where the slope of the tangent line is specifically just equal to 0. Not any other number, just 0. And then f prime of C is equal to 0. So that's Rolle's theorem. Then we moved on, proceeded on in unit 3 by talking about the first derivative test. And what the first derivative test, first thing we want to do is find the critical point by setting f prime of x equal to 0. We want to go ahead and remember that critical points can be found from the derivative and also the denominator of the f prime of x function. You put the critical points on a sign line, and you're going to pick points on the left side and right side of f prime of x to determine the slope. If f of x is increasing, then f prime of x is greater than 0. If f of x is decreasing, then the slope should be less than 0. And the relative max is if you have the slope changing from positive to negative, and if it's a minimum, it changes from negative to positive. Then we talked about second derivative, which tests your concavity. And of course, you find your critical points by finding f double prime of x equal to 0. And then just remember those critical points from f double prime of 0 can be found from the numerator in addition to the denominator of f double prime of x. You can take all the critical points and put on a sign line, and then pick numbers in between f double prime of x on the left side and the right side to determine the concavity. Now the graph is concave up if f double prime of x is greater than 0, which is something that you can do, okay? And it's concave down if f double prime of x is smaller than 0. And the point of inflection is located where f prime of x changes sign from a positive to a negative. Second derivative test, there's another method, second method for finding max and min, and the summary is if the second derivative test is a test for relative max and min and not for point of inflection, the second derivative test can be achieved as the first derivative test, and here are the steps. Find the critical point, take the critical point, plug it into the f double prime of x, and then here's a kicker because it's a little opposite. If f double prime of x is greater than 0, normally you think that it is going to be a maximum, but really no, it's not a maximum, it's going to be a minimum because the a value you're plugging in here is the critical point f prime of x, not f double prime of x. So just be careful with that. And then of course, if f double prime of x is less than 0, then there is a relative minimum or maximum, maximum at x equals b. And then of course, if f double prime of x equals 0, then you can just say the second derivative test is inconclusive and there is no max or min. That's basically it. So this was the second part of week 16 Wednesday. Hopefully you guys have the answers for that. All right, so let's go ahead and jump in on today's stuff. Here is the breakdown for today. So take a look at that. We're going to talk about two parts when it comes to related rates and optimization problems. So take a look at your guided notes. Your guided notes starts right here. This is going to be your first page. Second page is on related rates. Third one is on optimization. And fourth page is a review on interpretation of graph f prime of x and f double prime of x and sketching. So you don't forget how to do that. If you don't have a printer at home, or I mean, if you do have a printer at home, I'm going to go ahead and attach the guided notes, especially if you don't have a hard copy, onto MS Team. So I'm going to go ahead and new share this over here. Let's go back to calculus. So along with week 16 Thursday, I'm going to attach the guided notes for you guys. So if you have a printer, you can go ahead and print that out. Week 16 Thursday, and it's right here. Keep going. It might take a little bit because there's like 100 slides on there, so it might take just a little bit longer to do that. All right, so if you go ahead and click on this part right here, you'll be able to see the warm-up for today's lesson. In addition to your guided notes, if you have a printer at home, it's loading. You see the little circle there. There's 134 pages, but if you just want the guided notes, just go to the very bottom, the very last page. And on the very last page, you have your extra credit right here. So you want to make the copies for 130 all the way to 134. So there are 1, 2, 3, 4, 5 pages. Again, if you don't want to print it, that's totally fine. Make sure you just stop by and pick up a hard copy from me outside of B1. And I have it for this semester and also all of next semester for the first 9 weeks. So just keep that in mind. All right, so with that said, let's go ahead and get started with your assignment for today. So what I would like you guys to do today is turn to page 2 and page 3 of your guided notes. So here are some related rates questions. On the AP exam, I am like 100% certain they will have at least one of these questions. But the difficulty about related rates questions is that you just don't know which version they will have. And here's the thing with calculus that's very different than, I would say, algebra. Or the algebra, if you just memorize how to do certain things, then you're good to go. You could just memorize the steps. With calculus, you really have to truly understand the problem and be able to dissect the problem specifically and be able to apply the concept to certain problems. So this is kind of like the difference between the two levels of math classes with higher order thinking. So I have here 6 different versions of related rates problems. And I feel like with, this semester, the hardest questions are usually the related rates word problems, and of course the new optimization problems that you guys were just exposed to with the primary, secondary equations. And so I would suggest you take a look at these and then start reading them. Now, if you need the answers and the steps, I have the link right here, capital G, capital W, capital X. Go ahead and type that into your browser. And it is going to take you over here to this link, and you have the solutions for all of them. So for example, 1, just click on show solutions. And Paul Notes actually did a really good job typing the responses out and also the steps. So I would just challenge you guys to go ahead and take a look at this and, internally understand each of the questions. Now, similarly, part 2, which is page 3 of your guided notes, you have optimization problems. Similarly, same thing. You have 5 different questions on different types of optimization problems. I would just pick a few, try to start it on your own, identify the primary, identify the secondary problems, try to figure out which one are you going to use as a secondary to solve for one independent variable, substitute it back into the primary, find the first derivative of the primary, figure out the critical points, put it on a sign line, and then answer the questions at the very end. And once again, I have the link right here, capital C, capital Q, capital H. Type that into your browser. And that will take you over here to optimization. And the questions are right here given to you. And if you, of course, if you need the solutions, click on the solutions. There's a diagram. They identify the maximum, minimum. And then also, lastly, it gives you the answers at the very end. Okay. So that is what you're supposed to be doing today. When you're done with that, I have as a reflection right here. It says, what are the similarities between optimization problems and related rates? How are they set up with equations, differentiation, and finding the answers? How are the optimization problems different than related rates? And which type of problems do you prefer? So just make sure you answer that. All right, guys, I hope you have a wonderful week. As always, stay safe and healthy, and I will see you guys next time. Take care.